Hello and welcome, ladies and gentlemen. We are still in Packet 5, in and out and all about, talking about some area and perimeter. This video is going to be for activity 5.2. I'm hoping that 5.2 won't take multiple parts, but in order to do that, we're just going to get right to it. Okay, so here we have consider triangle XYZ with vertices 2, 5, 10, 9, and 6, 1. So it says determine the perimeter of this triangle, round your answer to the nearest hundredth if necessary. So for perimeter, we need to add up the distance of all of the side lengths. Before we can add up that distance, before we can add up that distance, though, we need to have all of those side lengths. So I'm going to have XY, do some calculations right here. Okay, so setting this up, I'm going to go X1, Y1, X2, Y2. Okay, so in this first parentheses, we have X2 minus X1, so I'm going to have 10 minus 2 squared plus Y2 minus Y1, which is going to be 9 minus 5 squared. That's going to be equal to the square root of 8 squared plus 4 squared, okay, which coming down here now is going to be equal to the square root of 64 plus 16, which is equal to the square root of 80, which is equal to 8.94. Okay, so that's for side xy, or for line xy. So we got one side down. So now for this line YZ, our next one, going to do some similar calculations. Okay, for YZ, I'm just going to leave Y as X2, Y2 because I already have it labeled here, and then I'm going to go X1, Y1 for Z. So for this first parentheses, we have X2 minus X1, so we're going to have 10 minus 6 squared, and then I'm going to have plus quantity, and now we're going to go Y2 minus Y1, so 9 minus 1. That squared. This is going to be equal to 4 squared plus 8 squared, which is equal to, or the square root of all that, which is equal to the square root of 16 plus 64, which looks a lot like our last one. 64 plus 16, 16 plus 64, that's all the same. So I'm just going to go ahead and skip this step, and we'll say that the length of this is 8.94 for line Y, Z. Okay. Last one we got to do. Let's do for line or ZX, okay? Just slide this up a little bit. So now we're going to do line ZX. Okay, and for this one, I did have, so these are both labeled as X1, Y1, X1, Y1. So I'm just going to change my Z values right here to X2 and Y2. Okay, so for X2 minus X1, that means I now have 6 minus 2, that quantity squared, plus Y2 minus Y1, which is going to be 1 minus 5 quantity squared. Bringing that down here, 6 minus 2 is 4 squared, plus 1 minus 5 is negative 4 squared. Okay, so this means that we have the square root of 16 plus 16, which is equal to the square root of 32, which gives us an answer of 5.66. And again, this was for line ZX. Okay, so now that we have all these side lengths, we can go ahead and add them all together. Down here at the very bottom of the screen now, I have perimeter is equal to 8.94 plus 8.94 plus 5.66, which is going to give me a perimeter of 23.54. Okay, so that's our perimeter here. So this is our answer for question 1 now. Okay, so now we're going to look at question 2. To determine the area, you will need to determine the height. How will determining the height of this triangle be different from determining the height of triangles in previous activities? So in previous activities, all of our triangles have either been right triangles or they've had their base on grid lines. So looking up here, okay, they've had their base on grid lines, which has meant that calculating the height, which in the last video I said is perpendicular to the base, so our height is always perpendicular to our base. That means that with this triangle, because none of our lines are on grid lines, are horizontal, that means that calculating our height won't be quite so easy. It'll require us to do some slope work instead of just counting up some squares. We'll have to do some distance formula, things like that. So how is it different? If you just want to put slope, if you want to explain that more, that's perfectly fine as well. And then for question 1, we did get that our perimeter was 23.54. Okay, so now looking at question 3, Jonas wanted to transform the triangle to make the calculations easier. Can you determine that Jonas did not transform the triangle correctly? So here we have his transformation. Okay, so apparently he did not do this correctly because we're trying to determine that he did not do it correctly. And so one thing that we know about rotations, similar to translations, is that rotations, and I'm going to go ahead and write this right here. So rotations don't affect size. Okay, and that's something that we should know. Okay, so rotations of shapes don't affect the size of the shape. So what that means is, if I rotate these points all like he's doing, so he's rotating it counterclockwise like this. So as Jonas is rotating these, that means that all of these side lengths should remain the same. That means that the area of the triangle should remain the same. Now, unfortunately, we don't know the area of the triangle yet, but we do know some side lengths. We said that this line right here, xz, was 5.66 from our calculations earlier. Okay, and if you look at this line, this x prime z, this rotation, after he's done this rotation, we can count squares, and he has it 1, 2, 3, 4, 5, 6 long. So the easiest way to determine that he did this incorrectly, or to determine if he did this correctly, okay, the best way to check is to see if everything is the same from this first triangle, this pre-image, to our post-image, okay, or this new triangle. So because these two side lengths that are supposed to correspond, so correspond meaning like this was the pre-image side, this would be the post-image side that corresponds to that, right? Because these are supposed to be the same and they're not, that does unfortunately mean that Jonas did this incorrectly. So to answer the question, how can you determine? You can just say check side lengths, and you could also check area, but again, we don't have that. Oh, side length. There we go, side lengths. Like I said, you could also check area, but unfortunately we don't have that information at this time, so that would not be effective for us. Okay, so now that was question 3. So I have my last video got cut off a little bit. iPad storage was full, so I have deleted some things and I am back. So we were working on this example. I'm just going to start it over and cut it from the last video, so here we go. Okay, so we're using XY, and I do have some markings from the last time I was talking about it before I got cut off. Let's use XY as the base of XYZ. So I have this labeled as the base. This is the side we're going to use as a base. You can draw a line ZW to represent the height. Remember that the height is perpendicular to the base. To determine the length of the height, you need to calculate point W, which is located at the intersection of XY and ZW. Okay, so right when I got cut off, so I was talking about how we have 3 objectives here. At the very bottom of this problem, this worked example, it's going to ask us to find the area of this triangle. So remember that the area of a triangle area is equal to 1/2 base times height. So that means that I need a base value and I need a height value in order to find the area of this triangle. From our first problem, problem 1, when we found the perimeter, we got side lengths of all of these things, and I actually already know the length of my base. I believe it was, let me double check my notes right here, 8.94, yeah. So the length of this, 8.94, and I'm writing that small just in case I need to draw some other things on here, okay? So this side is our base, and its length is 8.94, so I already have a base value. The next thing I need to determine our area is a height value. In order to determine our height value, okay, I need to make a height, okay? In order to make a height, I need to know where, or I need to know the slope of our height, okay? Once I know the slope of our height, then I can put a point on our base and then connect that with the height, or to connect that with point Z, and then once I have that, then I can calculate our actual height. So I need the height. In order to calculate that, I need a point so that I can do some distance formula there, okay? So that is what this worked example is going through, but I wanted to make sure to work through it for people who maybe missed that day of class, or maybe who were in class and were a little unsure about it. I just wanted to explain it again, okay? So this line says, remember that the height is perpendicular to the base. So that means when we said that perpendicular lines have opposite reciprocal slopes. Okay, so we know that perpendicular lines have opposite reciprocal slopes. So the first thing they did is they took the slope of their base. They did it the fancy math way right here, but if you have a graph, you can always just count squares as well. Okay, so our height, or our rise over run from this point to this point is up 1 over 2. And remember, it's rise over run. So this is our up 1, and this is our over 2, right? So it's just 1/2. Perfect. Okay. So that means that the slope of our height is going to be perpendicular to that, which is the opposite reciprocal. So because this is a positive 1/2, okay, my opposite reciprocal, as I'm working to that, this positive will become a negative, and then 1/2 will become 2/1, which is equal to 2, which is what they have right here. Okay, so now I know that the slope of my height is going to be -2. I don't know where to put this line yet. I don't know where to put the point yet to connect with that, but we're going to figure it out. Okay, and actually the nice thing about having a graph is that I could, okay, from z, a little bit of a shortcut, from z, if I know that the height is negative, or if I know that the slope of this height is going to be -2, I could just plot a line with slope -2 from z, and then I would hit my point W on here. But okay, we are going to be asked to do this without a graph, so we need to practice this and learn this so that we can do it without a graph. Okay, so now we have our slopes. So now next thing we need to find, once we have our slopes, okay, we can write a couple equations. That's what's happening right here. And then once we have those equations, we can set them equal to each other and get this point W that's going to go on our base. Okay, so the reason that we need two equations is because we have two variables that we're trying to solve for. We need a point, and remember points are in this form x, y. This is an ordered pair. So I need to solve for two variables. Okay, and if I ask you to solve for two variables with only one equation, we don't know how to do that. I don't know if we will ever know how to do that. But if we have two variables and two equations, then we can do some math magic, okay, and then solve for one of them, and then plug it in and solve for the other, and that's exactly what we're going to do. Okay, so an important thing to notice about this is that this, okay, and it's the same right here actually, okay, these lines, these look different than slope-intercept form. So the form that we're used to working in, y equals mx plus b, that's called slope-intercept form, right? This is the slope, this is the intercept, and it is the y-intercept, okay? This form that I've circled twice now, this is known as point slope formula, okay? So point slope, that's this one, okay? And actually over here too, but I'm not going to draw an arrow just because it'd be too much. Okay, so these are both called point slope formulas. So in order to write a slope intercept form, we need a slope and we need an intercept. Okay, we need both the things that are in the name. Math people weren't super creative on this. Same with point slope formula. In order to write a formula in point slope form, we need a point xy, a point xy, and we'll label it as x1, y1, and then we also need a slope. Okay, so for our base, okay, remember we're working on point xy, or on this line xy, excuse me, they needed to pick a point off of this line. Okay, so now most commonly the easiest thing to do is just pick one of your endpoints of the line and use that as your point for point slope formula. Okay, so they picked x, you could pick y if you wanted, nothing wrong with that, but they picked x. So point x is, and it's actually right here, point x is at 2, 5, so that's the point that they chose, and then the slope is what we calculated earlier by counting our squares or doing this formula right here for slope. Okay, so that means that our slope, or excuse me, so now we're going to plug this in. So this is point slope formula. So I'm going to plug all this information, x1, y1, and then my slope m. I'm going to plug this all right into here. And you can see that's exactly what they did, right? y1 is 5, y1 turns into 5. x1 is 2, x1 turns into 2. Our slope, m, is 1/2, m turns into 1/2. Okay, so they just plugged everything in. Now, I want to take this from point slope formula and turn it into slope intercept form because that's the form we're most comfortable with, and it's going to be easier for us to solve for these two variables when we have it in slope intercept form. So the way that they do that, okay, they actually kind of skip a step here. I'm going to grab an extra sheet of paper. Okay, so what they do, so we have y minus 5 equals x minus 2, oh, and actually, sorry, this should be 1/2. So y minus 5 is equal to 1/2 times this quantity x minus 2. So what they do, they distribute, remember we multiply by everything in the parentheses, so now y minus 5 is equal to 1/2 x minus 1. The reason it's minus 1 is because -2 times 1/2 is negative times a positive, it's going to be negative, and then 2 times 1/2 is 1, okay? So now I want to solve for y. I want to get it on its own because in slope-intercept form over here, okay, y is on its own. It's isolated. It's y equals something. So I want to get this to look like that. I want it to be y equals something. So I'm going to go plus 5, y equals 1/2 x plus 4. So they did these two steps. They did this distributing and this addition all in one, like in one line, which I know confused some people. So there's the work to do that. So now we have this in slope-intercept form, which is awesome. Okay, so we went from having one point and a slope to slope-intercept form. Okay, so now we're going to do that again with our height. Again, remember, okay, we need a point on our line, ZW, and then we need a slope. So like I said with the last one, for XY, the easiest points to pick are normally your endpoints. Okay, the same is going to be true for line ZW. Now, unfortunately, we don't know where W is going to end up, so that means that we should probably just use Z as our point. Now, that's exactly what they did. And again, Z is at 6,1, it says. So we have Z equals 6,1. Our slope is -2. So in this case, this is our x1, y1, and then our slope, m, is equal to 2. So again, from here to here, from this line to this line, they're just plugging things in. x1 is 6, x1 is 6, y1 is 1, y1 is 1, and then our slope is -2, m is equal to -2, so m becomes -2. And again, they skipped some steps here. I'm going to go ahead and show them just so that everyone can see them. So from y minus 1 equals -2 times x minus 6. Okay, that was all just plugging in numbers. Now we get to distribute this -2 plus 12, because -2 times -6, negative times a negative is a positive, and then a 2 times 6 gives us that 12 there. Okay, so now again I want to solve for y, just like the last one. So y is equal to -2x plus 13, okay, which is exactly what they got right there. Again, they just skipped some steps. I wanted to show all of those steps for you guys, but that is where we are at, okay? So remember our objective, we want to find an area. In order to find the area, we need a height. In order to find the value of our height, we need to be able to do some distance formula. And in order to be able to do distance formula, I need a point W for my height ZW so that I can calculate that. So here we go. Okay, so now we have these two equations. So now we're going to do some system of equations, which I was jokingly calling math magic. Okay, we're going to do a system of equations. So what they did, okay, y equals 1/2 x plus 4. Okay, and then y is equal to -2x plus 13. You can see that they set these two things equal to each other. I know that this step for some people can commonly cause some frustration or some confusion. So how about we do this, okay? I guess let's start like this. We know that y is equal to y because y is y, right? 1 is equal to 1, 2 is equal to 2. Something is always equal to itself, right? So if my two equations, I have y equals 1/2 x plus 4, but I also have that y is equal to -2x plus 13. So y, even though it's the same value, y is equal to y, it has two different ways to find that value. So what I'm doing now is I'm taking this y, okay, I'm taking this one, and I'm going to plug it in right there for that y, and then I'm taking this value of y, and I'm plugging it in on this right value. And you can see that's exactly what they did, right? This 1/2 x plus 4 is right here. This is our first y, and then -2x plus 13, that's our second y, goes right here. Okay, so now what we're going to do, and I want to show this because I think that they skipped some steps. Okay. So now what we need to do, now, okay, I have one equation and one variable. Earlier I was saying that two equations and one variable is no good. Two equations, two variables is good, and this is why. I can set them equal to each other, and now I have one equation with one variable that I'm trying to solve for. So 1/2 x plus 4, -2x plus 13. Okay, so now we want to solve for x. I want to get all of my x values on one side. I'm going to go ahead and add 2 because I don't like fractions and I don't like negative numbers, and by subtracting this 1/2 I would get a negative and a fraction. You can do that, there's nothing wrong with that, but I'm just going to go ahead and do it this way. So this -2x plus 2x goes away. 2 is equal to 4/2, right? 2 is equal to 4/2, just over here. 2 equals 4/2. So 1/2 plus 4/2 is 5/2. 5/2x plus 4 is equal to 13. Now I can subtract 4. I get 5/2 x is equal to 9, and then moving up here because I'm running out of room. Okay, the way that we can get rid of this 5/2, there's a couple ways. We can divide by 5/2, or the way that I think is easier is we can multiply by the reciprocal. Multiply by the reciprocal on both sides. Okay, and once we do that, this 2/2 and 5/2 will cancel, or 2/5 and 5/2 will cancel, so then I'll be left with x equals, and then remember and that's 9/1, I know it's at the very bottom here, okay? When we multiply fractions, we multiply straight across the top, straight across the bottom. So 9 times 2 is 18, and 5 times 1 is 5. So that means that our x, okay, is equal to 18/5, and that's exactly what they have right here. They just did, so what I did is I moved this x over, and then I moved the 4 over. So what they did is they did both those steps in one line of work instead of in 2 lines of work, and I just wanted to show those to you guys so you could see them, okay? So now I have x is equal to 18/5. So now what do I do with that? Okay, so now that I have this value, I can solve for x, because I have 2 equations that are equal to y that need an x value in them to solve for them. Well, now I have an x value. Okay, so I'm going to take that, and this is what they're doing right here. You can choose either of these solutions to use. You're just going to plug this x value in. You're either going to plug it in here, or you're going to plug it in here. Okay, either way you're going to get the same answer, because both of these y values, like we said, they're equal to each other. So if I plug in x here, I should get out a number. If I plug in x here, I should get out that same number. So you can pick either one. Again, I don't really like fractions, so I'm going to stay away from this. They decided to do the same thing. So they write this to signify that this is the equation that they're going to plug in for x. So they take their 18/5, they plug it in for x right there. Okay, and now they have y is equal to -2 times 18/5 plus 13. And then in this line, okay, from here to here, they just did all of their computation. Basically, they put it in their calculator and got out 29/5, okay, which is, in fact, correct. Okay, so now what that means is, for point W, we're going to be at the ordered pair 18/5, 29/5. Okay, so that means that on our graph now, okay, there's our graph again. Our graph, if I was going to put this point here, I'll slide everything up a little bit. Okay, point W is at 18/5, 29/5. So if I was going to graph this, 18/5 is a little over 3. It's like 3 3/5 if you want to do the mixed fraction. So I'll go to 3 right here, and then 3/5 would be like right in there-ish. Okay, again, because it's fifths and because we don't have tick marks, it's a little hard to tell, but 3/5 would be right about there. And then 29/5 is going to be 5 4/5. So 5 4/5 is just going to be like right under 6. And again, that's just a mixed fraction there doing that. So now I'm going to come up to where these two meet, and you can see my drawing's imperfect because I'm human, but you can see that point W would be somewhere right about there. So now if I connect W with Z, there's my height. And so because of the calculations we did, again, my drawing's imperfect, but because of the calculations we did, I know that this line that I've just now created will be perpendicular to the base, which is what we needed. Okay, so that was all an example. Again, our objective was to find the area. In order to find the area, we need a base and a height. We already have the base, so we need to find the height. In order to find the height, I needed a point on XW, or excuse me, on XY. I needed a point W on XY that allowed me to do some distance formula to calculate this height. So now we get to do that. We get to calculate the height, and we get to calculate some area. Okay, so identify the coordinates. Identify the coordinates. That's what we just did right here, so I'm not going to rewrite that. You could take this and throw it right there. Perfect. Okay, so now part 5, determine the area of this triangle. So A says determine the height of the triangle, so I will need to do some distance formula. So I have my line ZW, and I need to do some distance formula. So I'm going to say that this is x1, y1, and then point Z is actually still right up here. It's 6, 1, so I'm going to make that 6, 1. I'm going to make that my x2, y2. I already had it labeled up here, so I just rewrote it so that for our distance formula we can see that, okay? So this first parentheses is x2 minus x1, so it's going to be 6 minus 18/5 squared plus y2 minus y1, so 1 minus 29/5 squared, okay? So if you combine those, I'm going to just go over here. If you combine those, you get a -12/5 here squared and then you get 24/5 right there. And when you square those, okay, this is where this one gets a little crazy, and people who don't like fractions, I apologize in advance. Okay, this becomes 144 over 25 plus 576 over 25. Okay, we're still doing the square root of all this. Okay, so if you take these two fractions, you put them together, and you get a decimal, you get the square root of 28 point, or excuse me, not 58, 28.8. Okay, so the square root of that, remember we still haven't taken the square root of this, and the square root of 28.8 is 5.37. Okay, so that is our height value. So now is actually the easy part. Okay, now we get to do the area. Area is 1/2 base times height, and we know that our base is still equal to 8.94. So our area is going to be equal to 1/2 times 8.94 times our height, which we just found is 5.37. Okay, and so throw that into your calculator, and you should get, okay, 24, and I got 0.001, I believe, so just 24, okay, for our area, and that was our area. Okay, cool. So that was the first part. So now what they want us to do, okay, for the rest of 5.2, we're going to do that a couple more times. We're going to do that that same process. So first, though, it says, you know that any side of a triangle can be thought of as the base of a triangle. So basically it's saying that if we look at our triangle right here, I can use any side as the base. We just did x, y. So now for the rest of 5.2, we're going to do y, z, and x, z. Okay. So question 6, predict whether using a different side as the base will result in a different area of the triangle. Explain your reasoning. Well, if I use x, y as a base, then my area, or my triangle, is this big. If I use y, z as my base, then my triangle is this big. If I use xz as my base, my triangle is still this big, right? So no matter what we use as our base, whether it's xy, yz, or zx, okay, all of those sides doesn't change the area that's inside this. So I'm going to predict that it won't change. Okay, so now let's consider your prediction. So we have this triangle graphed on the coordinate plane. This time consider side xz. So we're going to use this side now. Side xz as the base. Okay, so now this is our base, and our length from earlier was 5.66. So those are both values that we'll want later. So part A says let point V represent the intersection point of the height, YV, and the base. Determine the coordinates of point V. So remember, to determine the coordinates, I want an x, y. I need two variables solved for, which means I'm going to need two equations. In order to get two equations, I need 2 points and 2 slopes. Okay. Luckily, one of the slopes is already given to us. The slope of, so we're going to have our base xz, and then our height, which we said is going to be yv. Okay, so for our base, I already have the slope of that. I can just count squares. Okay, it's -1, which means that the slope of my height is going to be the opposite reciprocal. So -1 is the same as -1/1. So from negative to positive becomes a positive, and then 1/1, the reciprocal of that is still 1/1. So this is just a +1 slope. Okay, so now I have the 2 slopes, boom, taken care of, check. Okay, now I need 2 points. So we said that the points that are easiest to pick are normally endpoints. So for this one, okay, I can pick x or z. I'm going to pick z. Okay, so I'm going to have 0.61. And then for yv, remember, I don't know where v is going to be. It's going to be somewhere along this line. But y is going to be up here at 10.9. Okay, so now I get to put these into point slope form. Okay, so remember, this is point slope form. I haven't plugged anything in yet, but I am going to make this my x1, y1, and then I'm going to plug in for this. Okay, so y1 to y1, so I have y minus 1 equals slope to slope, -1 to m right here, times x minus x1, which is 6. Okay, now I get to solve for y. So y minus 1 equals -x plus 6. Okay, And then, so I'm going to go plus 1, plus 1. I get y is equal to negative x plus 7. So that's one of my equations. Okay, this is for my base. This is my equation. And then for my height, I'm going to do the same thing. Okay, here's my point slope form. I'm going to make this x1, y1. So y minus y1 is going to be y minus 9. M times x minus x1 is going to be m1 times x minus x1, which is 10 right here. I'm going to distribute right there, so x minus 10, and then plus 9, plus 9. So y is equal to x minus 1. Okay, now I have these two equations. We said that y is equal to y, and that I have a couple different y's, so I'm going to set those equal to each other. So I'm going to go negative x plus 7 equals x minus 1. I can solve for x now. I'm going to go ahead and add an x over here because I don't like messing with negative numbers. So then I'll get 7 is equal to 2x minus 1, plus 1 plus 1. 8 is equal to 2x, divide by 2 on both sides, and then I get 4 is equal to x. Okay, so now I have one of my two values that I'm looking for. Again, now that I have this, I can plug it into either one of these equations. Neither of these are very hard. I'm going to go ahead and plug it into here. So I'm going to go y equals 4 minus 1, which means that y equals 3. Okay, so that means that my point of intersection, my point V, is going to be at the coordinate 4, 3. So now coming back up to our graph right here, if I go to 4, that's right here, and 3 right here, plot that, okay, that's point V. Now I can connect this, and again, my drawing's imperfect because I'm human, but we know that that's perpendicular. Okay, so now we've done all the hard work. We've gotten this coordinate. These two things combined give us that. So if I circle all three, that's just combining these two to go right there. Cool. Okay, that was part A of 7. Part B of 7. Sorry, it's just fiddling around with my paper up there. Part B of 7 says determine the height of x, y, z. Okay, so my 2 points, I just said that point V, or we said that our height was at yv. Okay, so point y is at 10, 9, and v is at 4, 3. Whoops, 4, 3. So I'm going to use that as x1, y1, x2, y2. And I'm going to do some distance formula. Okay, so 4 minus 10 quantity squared plus 3 minus 9 quantity squared. That is going to be negative 6 squared plus negative 6 squared, which is going to be the square root of 36 plus 36, square root of 72, which is equal to, let me find, here, I'll use my calculator really fast. I'm using my phone calculator. This is a great use of your resources, potentially, if mine will go. Why won't my orientation change? Okay, well, there you go, 72, and my thing doesn't want to move. So I guess I'll just ask Siri. Hey Siri. Oh. Hey Siri, what's the square root of 72? She's thinking.
The square root of 72 is approximately 8.48528.
So 8.49 we're going to say. Sorry about that technical difficulty. There we go. So that is our height. Okay. So now, once we have our height, we already had our base. This becomes the quote-unquote easy part, right? Area equals 1/2 base times height. We said that our base was 5.66, and our height was 8.49. So now this one I actually can plug into. Actually can plug this into my calculator. Okay. So 5.66 times 0.5, which is 1/2. Okay, so that's going to be 2.83 times 8.49, and then times 8.49. Boom. So 24.03. Okay. If we round to the nearest hundredth. Now, if you remember, okay, our last one was 24.001. Now that is slightly different, okay, but still very, very close, right? The only difference there is just some rounding. So I am at 27 minutes on this video. I was hoping 5.2 wouldn't take this long. But there's only one more problem left, one more problem just like this one. Okay, so I'm just going to go ahead and do it. It'll be a real long video. I know you guys are loving these. So here we go, last one, okay? So triangle XYZ is graphed on the coordinate plane. It's the same one we've been working with. Determine the area using YZ as the base. Okay, so now we're going to use this side as the base, and its length is 8.94, because remember XY and YZ, both these sides had the same length. This one was 8.94, so this one is also going to be 8.94. Okay, so now we want to we're using YZ as our base, so that means that my point X, I'm going to have some point X something. Okay, so we'll go ahead. We did let's see, we started with ZW, then we did YV, so we'll just do like, I don't know, XM for Mr. McGill. Okay, so we want to find some point M that goes on this base to make a height here. Okay, the way we do that, I need an X and a Y value, which means I need two equations. In order to have two equations, I need 2 points, 2 slopes. Okay, so we're working with our base, which is ZY, and then we're working with our height, which we said is going to be XM. Okay, so for our base, the slope of our base, okay, again, we can just count squares here because it's on a graph. I kind of made it kind of hard to see, but it goes up 2 over 1. So this slope's equal to 2. And then the slope of our height is going to be the opposite reciprocal of that, -1/2. And I am working a little quicker on this just because the video is already sort of long, but here we go. Okay, and then the point ZY, I can use either of these points. I'm going to go ahead and use point Z, which is at 6,1. And then for XM, again, I don't know where M is going to be, so I'll use point X, which is at 2,5. Okay, so remember point slope form. Okay, I'm going to plug this. This is going to be X1, Y1. I'm just plugging these in. Now I'm distributing. Oops, -12. Okay, and then +1, +1. So now I get Y equals 2X minus 11. So that's one of my equations. Now for this one, okay, this is going to be X1, Y1. So I'm going to plug these in. Y minus 5 equals -1/2 X minus 2. Okay, so I got my 2 equations now. If any of that was too fast for you, you can pause and look at each step to see what I did. You can slow it down as I work through those to kind of work along, whatever you'd like to do. That's the nice thing about having it like this with YouTube. Okay, so now I have 2 equations. So I needed 2 variables. In order to get 2 variables, I need 2 equations. For 2 equations, I need 2 points, 2 slopes. I got my points and my slopes. Okay, check, check. We did those. And then now I have my 2 equations. So remember, y is equal to y. I'm going to set these 2 y values equal to each other. Oops, except for I want this to be -11. And then equal to -1/2 x plus 6. I want to solve for x. And I don't like negative numbers, I don't like fractions, so instead of subtracting this 2 across, I'm just going to add 1/2. Now, to be fair, I do have to use fractions no matter what, but if I subtract this 2, I'll have a negative value, whereas if I add this 1/2, I will have a positive value. So now I have 5/2 x minus 11 is equal to 6 plus 11 plus 11. 5/2 x is equal to 17. Multiply both of those. I'm at the very, very bottom of the screen. Here we go. Multiply both of those by 2/5. Okay, so now I get x is equal to 34/5. And then I can plug this in to one of these. Again, if I plug it into here, I have to do double fraction. If I plug it in here, I only need to use 1 fraction. So I'm going to plug it into there. So y equals 2, and then times x, which is 34/5 minus 11. Okay, y is equal to, when we multiply fractions, straight across the top, straight across the bottom, 68/5 minus 11. Okay, and then now I'm going to do some phone math. Okay, so here, I'll do it over here. So 68 divided by 5, that's 68 fifths minus 11. So 2.6, okay, which would be some fraction, but just for the sake of leaving this and not converting it back because my phone can't do that, I need to get a better calculator, we will leave it at 2.6. So then I might as well make our x value 34 fifths, a fraction or a decimal as well. So this would put us at 6.8, 2.6. Some of you who like decimals better than fractions are super excited that I did that. Some of you that like fractions better than decimals are bummed. Okay, this is just another way to show it. So 6.8 and 2.6 would be my m value. So if I go to 6.8, there-ish, and then 2.6, like right above half, okay, and you can see that that would put us, again, my drawing's imperfect because I'm human, and I messed up and drew like on this line 80 times, but okay, that would be xm. When we connect that with z, okay, it'll be perpendicular, which means that now we can do some height calculations, okay? So now I know the points of the height. I have a coordinates to work with, okay? So now I'm going to go over here and define the length of xm. I'm going to do some distance formula. X is at 2.5, and then our new point's at 6.8, 2.6, x1, y1, x2, y2. Okay, so 6.8 minus 2 squared plus 2.6 minus 5 squared, 4.8 squared plus 2.6 minus 5 is going to be negative 2.4, yeah, 2.4 squared. And I can't do these ones in my head, so back to some phone math. Okay, 4.8 squared, 4.8 times 4.8, 23.04 plus, okay, and negative 2.4 times negative 2.4 is just going to be a positive number because negative times negative is a positive, so I'm just going to go ahead and put in 2.4 times 2.4, which is going to be 5.76, okay? And then actually, sorry, I'll keep this up here. Now I'm going to add those together to get 28.8, and then the square root of that, I think we actually just did that earlier. Yeah. Square root of that is going to be 5.37. Okay. So that means this is my base over here. Okay, back over here. Base, height, 5.37. Okay, and then now I'm going to do some area equals 1/2 base times height, which is going to be 1/2 8.94 times my height, which I just found this is the same as my height, right? Times 5.37. We're doing this live, folks, and by live I mean kind of live because you'll see it later, but there's an email. Okay, 8.94 times 1/2 is 4.47 times this 5.37 gives me 24.00. Okay, so in doing it live, we clutched up. We got the same answer every single time. Okay, so we got about 24. Again, on the one we got 24.03, but that's okay because it was very, very close. So compare the three areas you determined for triangle XYZ. Was the prediction incorrect? In question 6 correct? So our prediction was that all the areas would be the same. Compare the three. Was your prediction correct? Yes, they were all the same. Okay, and I believe if I flip this over, oh, there you go, that was the one before. So now we are, in fact, on 5.3. So hope that wasn't too scary. If you have questions on it, let me know. I will catch you guys in class. I hope you have a wonderful day. 5.3, we'll be talking about some composite figures. So have a good one. See ya.